Hi, I'm Ms. Cho, and in this video, we'll solve polynomial equations. Before we get into the specifics of how to do that, let's recap what it means for two polynomials to be equal to each other. When we're looking at them graphically, this means that we are looking at their points of intersection. So if we had these polynomials like this, our points of intersection are here, here, and here. And this only shows us real zeros. It won't show us imaginary zeros. And when we look at this algebraically, it means that they have coordinates in common. That means if I plug x1 into the polynomial, I get one output. And if I plug that same x into g, I get the same output. Let's take a look at an example. In this example, we're asked to solve algebraically this equation. 10x cubed plus 2x squared plus 13x is equal to 11x cubed plus x squared minus 35. When we do this, it's like solving quadratic equations. We're going to set our equation equal to 0, and then we're going to find our zeros. So let's start with step 1, setting our equation to 0. When I do this, I like to look for my highest degree exponent. And I want that to be positive because I don't like factoring with negative leading coefficients. So I'm going to take my my 10x cubed, and I'm going to move it to the right side. And then I'm going to move everything else on the left over to the right using inverse operations. So I'm going to subtract the 2x squared, and I'm going to subtract the 2x squared, lining that up with my x squared. I'm going to subtract the 13x, and I don't have an x term, so I'm just writing it off to the side. And so then when I add, all my left side cancels out to 0, and I have left on the right x cubed, a negative x squared, negative 13x, and a negative 35. And the reason I'm writing this in this order, so it's in standard form with exponents in decreasing order. Now that I've set my equation equal to 0, I can find zeros any way I know how. Before, we've talked about factoring with GCF, but I don't see a GCF here, so I don't think that's going to work for us. I could try to factor by grouping, like if I had x cubed minus x squared as a group, and then negative 13x minus 35 as a group. I could factor out an x squared here, leaving me an x minus 1. And then I could factor out negative 1 here with a 13x plus 35. But these two are not common factors, so I can't really go anywhere from here. So I don't think that's going to be a really viable option. I could try to use a polynomial identity, but this doesn't really match any template that I know. And so I think my best bet is going to be to find a 0 on a graph and then use long or synthetic division. And the reason why that works is if I say that 4 is a factor of 248, that means that 4 times something is going to be 248, and I can find what that something is by dividing by 4. So in the same way, I'm going to look for my 0 on this graph, and I'm going to divide my polynomial by that 0 and help to find the other factor. When I look in the graphing calculator, I zoom out and I see that I have a real 0 at x equals 5. And I don't have any other zeros, so I'm just going to go with that. I'm going to use synthetic division, but you can use long division if that's what you prefer. So basically I take my 0 of my divisor out front, and then I write down the coefficients of my polynomial. So I have a 1x cubed, a negative 1x squared, a minus 13x, and a minus 35. If you don't remember how to do synthetic division, that's okay. You can check out my video. But basically what I'm going to do is going to carry down my leading coefficient, and then I'm going to multiply my 0 out here by everything that's in this bottom row, and then carry it up and add, carry it up and add, carry it up and add. So my 5 times 1 is 5. When I add that, negative 1 plus 5 is 4. 5 times 4 is 20. And negative 13 plus 20 is 7. 5 times 7 is 35. And negative 35 plus 35 is 0. And I'm going to box off this last spot to remind me that's my remainder. My remainder is 0, which means that this is a factor. And I'm going to rewrite my factor with my exponents. So this is 1x squared plus 4x plus 7. And now I can know that my factors are x minus 5 and then x squared plus 4x plus 7. And when I have that equal to 0, I can use the zero product property I can set each one of these factors equal to 0 in order to find what my zeros are. I'm going to recopy this on a new page so that I have a little more room. Since I am now looking for the 0 of this quadratic factor, I can do that a couple of different ways. I could factor it, I could use a quadratic formula, or I could use the completing the square. I'm going to use the quadratic formula because I know that always works. It's personal preference, use whatever you like. So it's minus 4b squared over 4ac over 2 times a. My a is 1, my b is 4, and my c is 7. So then I can substitute that in as negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 7, which is all over 2 times 1. And that's negative 4 plus or minus the square root of 16 minus 28 over 2, which then is negative 4 plus or minus the square root of negative 12 over 2. The square root of negative 12 is equal to, I know because there's a negative, there's going to be an I. The largest perfect square that divides into 12 is 4, so the square root of 4 is 2. And then 4 times 3 is 12. So then I have 2i plus 2i root 3. So that means I can rewrite this as 2i root 3, and then I can divide 2 from each term. So that leaves me with negative 2 plus or minus I root 3. That means when I put it all together, the solutions of this equation are x equals 5, x equals negative 2 plus I root 3, x equals negative 2 minus I root 3. Let's summarize. When we're solving polynomial equations, the total number of zeros will be the degree of your polynomial after you set it equal to 0. And these zeros, they can be real or they can be imaginary or complex. And if you're looking at a graph for points of intersection, you will only see the real zeros. You'll need another method to find the imaginary ones. To solve, you're going to set your equation equal to 0, and then you're going to find the zeros using any method that you like.